Hey students, welcome back to examples on transformation of quadratics. We're just going to do one example. So let's go ahead and write down the instructions for the example. So for this one, we are going to write uh, write the given function, in vertex and transformational forms, in transformational forms. Vertex and transformational forms. Analyze the resulting graph. Analyze the resulting graph. The resulting equation. Analyzing the resulting equation and sketch a graph. And sketch a graph. Okay. All right. Now, for example one, we're going to work on the equation y equals 1/3 x squared plus 2x minus 2. Okay. So this is the equation. If you notice, this equation is in standard form, so we want to write it in vertex form. All right. So to make this happen, we have to complete the square. So this 2 has to move over to the other side. To do that, we just add 2 to both sides. Add 2, and that yields y plus 2 equals 1/3 x squared plus 2x. Okay. Now to complete this square, we want this expression on the right to be written in the form x squared plus bx. All right. In the parentheses, we do not need any coefficient for x squared, so we can root it with ease. Okay. So to accomplish that, this 1/3 has to be factored out of this first term and the second term. All right. So we're going to factor out 1/3. We'll have y plus 2 equals 1/3 x squared plus 6x. Okay. All right. Now, how on earth did that happen? How did 2 become 6 when I factored out 1/3 from it? Just to illustrate, we can take 2 to the side here. What I did when you're factoring out is as though you were dividing, right? So if I factor out 1/3 from 2 is as though I'm dividing 2 by 1/3. So how do you evaluate this expression right here? To divide by 1/3 is the same thing as to multiply by its reciprocal, which is 3/1, which is 6. So every time you divide by a fraction that's less than 1, and between 1 and -1, you're going to get a bigger number. Okay, so they have it. So when I factor out 1/3 from 2, I have 6. Okay, notice that 1/3 times 6 is what? 2. All right, now we're going to complete the square. Remember, to complete the square, you just need to multiply by b over 2 square. Okay, so in this case, b is the coefficient of x. B is equal to 6. What do we do with that? Divided by 2, which is 3. And then that's b over 2, and then we have to square it. So b over 2 squared is 3 squared, which is 9. All right, so on the right side, we're going to insert that 1/3 x squared plus 6x, and we're going to add the 9 and put it in blue, plus 9. All right, so if I introduce 9 to the right side of the equation, what do I introduce to the left side of the equation? So y plus 2, what do I add here? I added 9 in the parentheses. So out here, I'm going to add 1/3 times 9 to the right side, because this 1/3 is going to be distributed to everything. So the constant is going to be 1/3 times 9. So even though I introduced 9 in the parentheses, to the right side, I introduced 1/3 times 9. So on the right side, I'm going to introduce plus 1/3 times 9. Okay. Let me write that in blue so that you can see what's going on. So plus 1/3 times 9. The reason again is as a consequence of distribution. Okay, 1/3 times 9. All right, so let's simplify the left side and factor the right side. The left side, we're going to have y plus 2. 1/3 of 9 is 1/3 of 9 is 3, right? Plus 3 equals 1/3. Now to factor this, we use the factoring trick. We just read the first and the last, with the first and the last, and bring down the middle sign. So we're going to have x plus 3 quantity square. All right, so we're going to have y plus 5 on the left side equals 1/3 x plus 2 square. Oh, x plus 3 square. Sorry about that. All right, now we have it in, this is transformational form actually. If we want to write it in vertex form, that's not going to be a challenge for us. So let's go ahead and start writing down the formulations of this equation, vertex form. So for the vertex form, we just move the 5 over to the other side. We have y by itself equals 1/3 x plus 3 squared minus 5. Okay, just minus 5 from both sides. And then the transformational form, transformational form, that's going to be this form right here. Y plus 5 equals 1/3 x plus 3 quantity squared. All right. Now let's go ahead and find our vertex. To find our vertex, you look for HK, or the opposite of the number next to the x is our x coordinate, -3. Opposite of the number next to y is the y coordinate, -5. All right, so there goes your vertex. Reason is because these are the values of h and k. All right. Okay, so we know our vertex. Next thing we need is our axis of symmetry. Axis of symmetry. The vertical line that divides our parabola into two congruent graphs. Axis of symmetry is the x coordinate of our vertex, so x equals -5. X coordinate of the vertex. What next is the opening. To find the opening, you just look at the sign of A, okay? So the opening of this parabola is a happy parabola, so it opens up. The reason is because A, which equals to 1/3, is positive, okay? So if we have a positive A, it's happy. If it's negative, it'll be sad, all right? Now the extrema in value, let's figure out what those are. Extrema in value. Since we have a happy situation here, a parabola opening up, we're going to have a low point, right? So that is going to be the minimum, and the value basically is going to be the y coordinate of our vertex, which is y equals -5. Okay, the value is y equals -5. All right. Now let's find the width. So when we're determining the width, all we are looking at is the size of the number, not the sign, right? So the width is going to be wider in this case. It's going to be wider because the magnitude of A, or the absolute value of A, is equal to 1/3, and 1/3 is less than 1. Okay, if it's less than 1, it makes the parabola wider. Okay, if the absolute value is less than 1, it makes the parabola wider. All right. Next thing we need is the translation. To determine the translation, we just look at the vertex and just follow the signs. So +3 means you go 3 units to the left, and then 5 and the -y means you go 5 units down. All right, or you can look at your transformational form and do the opposite. So this is up and down. So if you go down 5, the reverse. Side to side, you go to the left 3, the reverse. Okay. All right, now that we have all the information that we need, let's write down the reasons here. Coordinates of a vertex. Okay. All right. So now we need to draw our graph. So let's go ahead and draw the graph. Center is -3, 5, so we need a pretty big quadrant 3. Exaggerated downwards a little bit more than to the side. Let's create our parent graph. So to generate our parent graph, we're going to start from 0, 0. We have 1, 1, and then 2, 4. All right. So this is the graph that's been transformed. Make it dotted because this is not the actual graph. This is just the reference graph. So dotted through there. And then this graph right here is y equals x squared. Now, to generate the graph we need, we're going to go 3 units to the left. 1, 2, 3. And we go down 5 units. 1, 2, 3, 4, 5. So that was our new vertex. If we did not alter the width, it's going to go through 1, 1, and 2, 4. If we didn't alter the width, this is how it's going to look like. But since we have a wider scenario here, we're just going to make our parabola a little bit wider than these dots. So there go. Let's see, what is the y-intercept for this parabola? Take a look at it. The y-intercept is -2. Okay. So it's going to go through -2 for certainty. It's going to go through here. So you see how it's somewhat wider. So use symmetry to sketch that point. So it's going to go, oh boy, I missed the point. Anyway, something like this. And then wider than your typical y equals x squared. See, this one right here would be same size, but since a is less than 1, it's a little bit wider than that, okay? Let me fix this line right here. I want it to go right into that y-intercept, which is -2. So just a little bit. Let's go through there. So curve it a little bit. There you have it. Okay. Now let's label the graph. The line that divides the graph into two congruent graphs, known as the axis of symmetry. So this is a axis of symmetry. Axis of symmetry. And the equation is x equals -3. All right. This little point right here is the vertex. Hold the vertex, and the coordinates are -3 and -5. And then this point right here traced to the y-axis. This value right here is your minimum. Okay, it's your minimum, and the value is y equals -5. All right, and this is the original equation, which is y equals 1/3 x squared plus 2x minus 2. All right, so there you have it. So thanks so much for paying attention to this presentation. And feel free to subscribe just by clicking up here. Collection of tips can be found on markgrosserve.com. You can also share this video with your friends via Facebook or Twitter. Thanks again, and have a wonderful day.